Good morning, guys. So today we will be solving question number 43 of the classic Erudov series. So it's a very beautiful problem. You can see that well classified problem of circular motion. Each and every topic would be revised by this problem. So let's start it. Says a particle A moves along the circle of radius r. So here is the particle. Here is the particle and it will move along this circle. In which sense? Clockwise sense. Okay. The radius has been given, so its radius vector r relative to the point O. So here is the point O, and the omega is given as 0.4 radians per second. So the question is, we need to find the modulus. We need to find the modulus of the velocity of the particle and direction of total acceleration. So let's start it. So moving to the solution, you first need to know some basic things such as in circular motion. Okay, so let's start with the problem first. What's the approach? So in this type of problems, we first assume any parameters. For example, I consider this angle as alpha. So you can see that this is r, this is r, so it is an isosceles triangle. So if this is angle alpha, this would also be angle alpha. Okay, so let's consider this angle as beta. Okay, so what do you think by beta? Beta is the rate of change of position with respect to A. This point. Okay, so it is the rate of change of position with respect to A. So according to the triangle law, we can obviously say that beta equals 2 alpha. This is the first equation we can conclude from this point. By we also always know the triangle property that sum of an angle is equal to the sum of the opposite sides, the angle of the opposite sides. Okay, so beta equals 2 alpha. So if we look at point O, so O and alpha, what is alpha? If I write, let's see, if I write alpha, d alpha by dt is omega, d alpha by dt equals omega. So this is the second equation. This alpha should not be misunderstood with angular acceleration. This alpha is just an angle, okay? It's not angular acceleration. So this is the second equation. Let's differentiate first equation with respect to t. So we get d beta by dt equals 2 into d alpha by dt. Okay, so and d alpha by dt is what? It's nothing other than omega. So d beta by dt is 2 omega. Let's say it's equal to omega dash. So I hope you remember that if this is point A, at any circumference, it can be termed as the tangential acceleration is r omega. Okay, sorry, it's not that, it's the velocity. It's a velocity, it's r omega. So just put the value. So v equals r omega dash, because we consider it as 2 omega equals omega dash. So v equals 2 r omega. So this is the first answer. Okay, just put the value and get the answer. So what is the 1, 2? Radius is given as 50 centimeter, means 0.5 meters, and omega is 0.4. This comes out to be 0.4 meters per second. So this is the velocity. Then the first thing you need to know is that we need to let's find the tangential acceleration. So tangential acceleration is the rate of change of velocity, and you can already see that the velocity is 0.4 meters per second. 0.4 meter per second is a constant value. Okay, so at would be 0. So what do you mean by at equals 0? At equals 0 means that the particle would perform a uniform circular motion because in the tangential direction there is no one to change the speed of it, right? So at equals 0. Okay, let's see, this is a tangential. Let's talk about the centripetal acceleration, that is v squared by r. So what is v? V is 0.4 squared by, or what is r? R is 0.5, right? 0.5. So this comes out to be approx 0.32 meters per second square. So this is the second final answer. I hope you all understood it. Thank you for watching my video.